All right, you picking me up all right?
Hot stuff.
Yeah, oh yeah.
Okay.
Good level.
We'll get the camera. We got the mic on.
Yeah. Well, here.
Okay.
Oh, we're streaming all that shit, won't we? Start streaming. Start streaming. Override.
All right, are we good to go?
Yes, we're good.
All right, well, thanks for coming. Just going to talk a little bit. This talk is called Windows Timelines in Minutes. A little bit about me, Phil Polstra, a.k.a. Dr. Phil. And I teach digital forensics and computer security at Bloomsburg University of Pennsylvania. I'm required to put that part in. So what I'm going to talk about a little bit today is how you can create a timeline for a Windows system, and something you can do in minutes, not hours. If you've ever used a tool like Autopsy, how many of you have ever used Autopsy? Right. Autopsy is not exactly fast. I know that when you load it up, it comes up and it says open, flexible, fast, and I'm like, what's your version of fast, Mr. Carrier? I don't know, but so I'll show you how you can do stuff a lot faster than that. Also, how you can do things where you have some infinite flexibility. You know, you've got things backed up to a real database, so you don't just get whatever your tool came with in terms of views. Also, something you can do for free, no cost. It's all using Python, shell scripts, and a little MySQL action. Also, show you how you can make timelines that are either by file or chronologically. So I can either say what happened between this time period, or I can say, for this file, tell me every single time record for that file. So why should you care about this anyway? By the way, if you don't know, that's a Care Bear. Just saying. But so if you want to do an investigation, you have a system that might have been breached, or maybe you have another reason for looking at a certain system. Maybe it's a suspected bad guy system, etc. Having a timeline can be super useful. So this is a very common thing that we do in forensics when we're doing some incident response. Now, NTFS stores redundant timestamps, as was mentioned earlier today by Mick. And so the rules for updating those timestamps are a little bit complicated. And attackers, as it was also mentioned, might modify some of those timestamps, but not all of those timestamps. So having this information readily available can help you figure out, hey, somebody's manually altered some stuff. So now I'm going to give you guys the 5-minute tutorial on NTFS. I'll give you a little bit of warning. NTFS is something we spend an entire semester on at the university. Right? We have an entire class on NTFS file systems and how do they work and how do you analyze them. So we're going to do that in 5 minutes instead of 15 weeks. Right? So in NTFS, everything is a collection of attributes. So you have a file. It's a collection of attributes. Even the stuff that's in the file, the data that's in the file, is an attribute of that file. Directories are also a collection of attributes. So if you have a file, those attributes always include at least these 3 things. So we have what's called a standard information attribute. And this has a bunch of timestamps, has a couple other things as well, but it has timestamps. And you're probably familiar with MAC times, modified access and created times. NTFS adds another timestamp called a record change timestamp. So this is what we mean by MACR times. Right. So we got another one. So we have always that attribute. Standard information sounds like something everybody should have, right? And then we have at least one file name. You might have more than one file name. Common reasons for that: short file name, long file name. That's not the only reason, by the way, you can have multiple file names. I've seen some files that had 97 file names. And it was the same file, but essentially aliased a lot. I think that file was something like Notepad. It was just like everywhere. So it's like, whatever directory you're in, it's probably there. Which I thought was really weird. And then you'll have at least one data attribute. So that's the contents of the file. Now, if you really get into it, you can find out that you can have these things stored out in the regular data clusters. You can have it stored in this thing that I want to talk about a little bit. It's called a master file table, or MFT. So this master file table is a big central thing in NTFS. So it consumes a good chunk of the disk, and it has a collection of all these attributes. So every file or directory has a 2-sector or 1024-byte set of these attributes that is an MFT entry. So that's a file. If you say, what about a directory? It's very similar. It's slightly more complicated. It has standard information, at least one file name. And then the way that they store directories, you have this thing called an index root. That's sort of the start of a tree. So directories are stored in a tree structure. It's not an awesome tree structure, but it's better than having a flat structure. So it is a little bit faster, and it's kind of weird to analyze it because you start out and you have a couple of things inside this MFT entry, and then it grows a little too big, and then they put things out in data clusters in something we call an index buffer or an index allocation. So, they have all the same information. If you look at the raw disk, this is a tool. It's called Active@ Disk Editor. It's a free tool. It works on Windows and Linux. If you go to disk-editor.org, you can download this tool for free. So this is just showing you an entry, in this case for the root directory. And you can see here I have attributes, $10, that's that standard information, $30 is the file name, $90 is this index root thing, and that's this yellow bit. And if you look over here, you can see some text, and that text is related to entries in that root directory. Right? And it points to these A0 attributes, which are those index allocations. They say, okay, here's the clusters you have to go read in order to get that information. And that's down here in this purple bit. We're not going to talk about how to decode all that stuff, because we're really interested in timestamps. See, I touched the cable, lost my video. Okay. Step back from the computer.
But it's HDMI, so there's no way I know to fix that because it's not.
Oh, this is actually green. That's my actual background. I don't know. I just randomly picked green. Yeah, it's not an RGB sync issue or anything weird like that. But so a little bit more about timestamps in NTFS. Right? You get resolution in hundreds of nanoseconds, also known as 0.1 millionths of a nanosecond. Of course, it's not as good as Linux. Linux, you get a whole, 1 nanosecond, not hundreds of nanoseconds resolution. But Linux is always better, right? You already knew that. And they do something insane. They store the offset since January 1st, 1600, because that sounds like a reasonable date for timestamps, doesn't it? Yeah. Not too many computers around then, but who knows? Who knows why they do that? They use 64-bit unsigned integers for this. It's a lot better than the fat timestamps, however. Fat timestamps are only good to 2 seconds resolution, and they don't have an access time. So in the Mac timestamps, the A timestamp is really just a date. and they don't have a record update time. So that's new. By the way, I'm not going to talk about it in this talk, but there is a way in Windows where you can change the behavior of that access timestamp getting updated. There's a registry key that you probably have set. But okay, so how can you easily extract this timestamp information? And I'm going to walk you through some things that are in this little book that I published this summer. You can go to this link at the bottom, windowsforensicsbook.com. You can download every single script from this book for free. So you don't have to buy the book, although you certainly can. And if you really want a copy, see me later. But so what you want to do is first extract this MFT, this master file table, as one big file. Now, there's a lot of things that you can do and a lot of processing you can do that's a lot quicker if you have that whole MFT as a file. You can also supply a image file, and that allows you to get those MACR times out of those index buffer things I was talking about. If you only give me an MFT file, that's all you're going to get, is standard information, file name, attributes, and that's it. So that's step one. So I have a little script, and just to kind of give you an overview of what this script does, it's going to go through every MFT entry. It's going to extract the file attributes and MACR times. And then it's going to get all the standard info attributes and get those MACR times and then fill in some of the gaps, things like file size that are not in the standard info attribute, and have entries for every single time that file's referenced. If you give me an image file, I'm also going to see, oh, there's an index allocation, or an index buffer, if you will. I'm going to go out to that cluster, and I'm going to grab all those records and process those as well. So here's how you would do this. A little bit later, if we have some time, I'll do this for you real time. And if you've ever used it before in Linux, how many Linux guys here? All right, this is my kind of people here. All right, okay. A lot of Linux folks. You're probably familiar with the time utility. If you're not, it's an awesome little thing that you can use. You just throw time in front of whatever command you want to run, and you get this little display here where it's going to show you how long it took for your command to run. This is great. I do a lot of video courses for Pluralsight, Pentester Academy, and it's nice because I like to speed up videos. I figure you guys don't want to sit and wait for volatility to run, and sometimes it takes a half hour to run a plugin. But this way, you can still see how long it actually took. How long did I have to sit there while I was recording it, and stuff like that. So you can see it took 1.3 seconds to extract the MFT from an image that I was using for this test. And then I ran my little script, which processed all of that 10.8 seconds. And I got 282,364 records. So that's not too bad. So let's call that 13 seconds total. And I was able to extract all that. So we'll go through those in a little bit. Step 2, create a database. Someone asked me once, they said, hey, Phil, why do you think all these other tools are so slow? I said, well, I think there's a couple reasons for that. But I think a big thing is that a lot of people, they're trying to store all this stuff in flat files, or something that's not exactly ideal. Whereas I'm just going to put all this stuff in MySQL. Now, if you don't like MySQL, you like Postgres, go ahead, do that. Use whatever database you want. But it makes a huge difference. So if you need to install MySQL and you're running Linux, if you don't run Linux and you start running Linux, then you're going to start hating anything else, mostly because it's so hard to install software. Like you're running Windows, you're like, oh, I wish I had I don't have this. But, Linux, if you type MySQL and you don't have it, you'll usually get a helpful prompt that says, you don't seem to have this. Here's the command to install it. Okay. So to get this on most versions of Linux, just sudo apt-get install mysql-server. That'll give you the server and the client. Then you need to create a database. That's the big overall container. MySQL admin-u, and then your username, which will probably be root. -p says, hey, please prompt me for a password. So you'll be prompted for that user, usually the root user, the admin user's password when you install this thing. Create, and then a database name. And then you need to create a table to store this metadata. So my little script will create a comma-separated value file with all this data in it, and then we need to put it into a database. So first we need a table. This table, I apologize, it looks a little messy here. If we have time later, I'll show you the SQL in a little bit nicer format. So I want to create a table I call files. It has a source. Where did it come from? Standard info, file name, or index buffer, and then all the date timestamps, file size, etc. So here's how you do that. And it took me about 3 seconds to create this database. Right? So far I'm up to what, about 16 seconds or so. And here's creating the table. Okay, 0.33 seconds. We'll round up. 17 seconds so far. So far, still not so bad. Okay. Now you got to load that stuff into your database. So how do you do that? MySQL supports this command, load data in file. You give it a file name. My file is terminated by semicolons. I said CSV. Technically, it's semicolon separated values. That's what I use. Things are enclosed with double quotes, new lines at the end. Ignore the first row. It's just a header in case you wanted to pull it into a spreadsheet program instead. Here's all this stuff. Now, this looks a little bit complicated, and the only reason that this looks a little bit complicated, you see all these at access date, at blah, blah, blah date. It's because there's more than one way to say the date, right? I can do year, month, day. I can do month, day, year. I can do day, month, year. And there's no way for MySQL to know which one I used unless I do something like this. So I'm using this stir to date function here that says this is the format I will provide it in. Year is 4 digits, month, day. So I did that. I imported 282,000 rows in 6.4 seconds. So let's say we're up to what, like 23 seconds, something like that. All right, still under half a minute. Well, now what? I could take this table right here and start doing queries. Those queries might be a little bit complicated, however, because all 4 of those timestamps are in the same table. So that makes the SQL kind of hard to write. And I don't want that. So instead, what I'm going to do is I'm going to create another table, kind of a cross-reference table, if you will. And that table just has an operation. Was it MAC or R? The source, was it standard info, file name, or index buffer? And then the date and time. and then a record number that points back to that files table. So that's my link between my two tables. Created that in less than half a second. Then I need to insert into this table for each of the 4 timestamps. So you'll see I have 4 insert statements that I did. And it looks like, 4, 2, let's round up. Let's call it 15 seconds, right? So I'm still, we'll say 45 seconds, maybe a little less so far. So now I'm ready to do queries, right? And query as much as I want. Okay. So I want to, say, review the entries in a certain time and date range. Right? I can do that. I can also look at a particular file. So if I have a large result set from any queries I do, I can also save those as a CSV file, and then I can import that into LibreOffice Calc or something similar. Now, because I'm lazy, and because I don't want to fat finger this query a lot, I wrote a couple of convenience scripts. Just some simple shell scripts. So here's one of them. So this one will allow me to print a timeline based on a date range. So here I have a usage function. How many of you have ever done any shell scripting in Linux? Okay, so a few of you. So Linux shell scripting is really not so bad. I currently teach an introductory Linux course at the university, and we're going through simple stuff like this right now. We're not getting super deep into it, but so this script starts with a special comment. It's called a shebang line. It's hash bang, and it says, what shell would you like to run? Because there's so many different choices, and I said bash, please. And here's how you define a function. This is a usage function. If you don't give me the right number of arguments, this is going to print out and say, here's the name of this script. Please give me a database, a starting date, and optionally an ending date. Here I say, how many command line arguments did you give me? If you gave me less than 2, I'm going to whine and give you usage. So over here is the real deal on this script. Right? Now, the first thing I have to say is disclaimer. I tend to write scripts that are simple and straightforward. I know that I could have written a shorter script, but I wanted it to be super simple and easy to read, and I didn't want to say, well, let me affect the SQL query, in the middle. I'm like, yeah, it's easier just to say, here's one case and here's the other. Right? So here's the first case. You didn't give me an end date. You gave me less than 3 things. What I'm going to do is I'm going to use a little trick that we have in shell scripting where I can say cat less than, and then some sort of marker. And I said, all right, what does that do? The following lines, up until you reach that marker by itself on a line, are going to be put to standard output. Right? So that says take all of this stuff, which is just a SQL query, and then that is piped to MySQL, the database name, and then the root user is used, and they're going to be prompted for a password. My query just looks like this. Select all these things from these 2 tables. Anyone never done any SQL queries in here? Awesome. Okay, so I'm not even going to explain that. You guys should understand this. Pretty basic query from 2 tables. I say the date is greater than or equal to the date you passed in, argument 2. Here's my join condition, and I order it by date descending, time descending, and that's it. Right? Here's my else. You gave me an ending date. Same trick. The only thing that's different is I have this greater than or equal to this date, and less than the second date. Right. So that's my query. I can go ahead and run that. Here's an example of running that, and a whopping 2.6 seconds. All right. Not too bad. All right. I'm still under a minute. Now, here's something I want to say about this. I'm under a minute here. This exact same data set that I used for this test. I did a training class in Norway last month. Some people said, hey, Phil, we would really like to learn how to use autopsy. Could we learn how to use autopsy today? I said, sure, we can do that. 9 o'clock in the morning. I said, all right, guys, after lunch today, we're going to use autopsy. So let's go ahead and start importing this information into autopsy so that at 2 o'clock, we can use autopsy. Right? So 5 hours later. Right? 5 hours later, most of them still weren't done importing into autopsy. Right? And, okay, so I can't even make a timeline because it's not done yet, versus this, is easily less than 2 minutes. So 2 minutes, 5+ hours. Maybe I should have it pop up a message when you run the script that says, fast, or something. No, then it would take 5 hours. Okay, so here's how you can do this. I ran this query. I got a couple of results. Let's say I got a query that returned a lot of results. So if I got a lot of results, I can import this into Calc. Now, most of the time, if you do a query in MySQL, and you just capture that to a file, all the values are tab separated. So when you go to import, just make sure that tab is ticked on one of your separator options. It probably is. Just make sure it hasn't been unticked. And the only other thing you need to worry about is that for the date field, all the rest of them, it can say the column type is standard. But for the date field, again, you have to tell it, how are my dates formatted? So you have to say it's year, month, day, please. Once you've done that, you can view it in Calc, like so, and you can look at these results. Now, in a little bit, I'll talk about what do these mean, but you can see here I've got a record change. That was from the file name attribute. And here's the file itself, and a little bit later you'll see standard info for the same file, etc. So you can say, well, what looks weird? What doesn't look weird? You have to understand a little bit more about how timestamps work to answer that. Here's another script. Now this one says, instead of looking at things in terms of time and doing a chronological thing, I'm going to look at it in terms of file by file. So if you look at the usage function, it just takes a database and optionally an MFT record number. Right? So we said that MFT thing was really central, and everything has an entry in the MFT. So if you know the record number, let's say it's 650. You say for the thing in 650, tell me every single entry, every single timestamp you can find on this file system that relates to that. And it's just another query. Slightly different query, and here my where clause is going to be a little simpler, where the record number is this record number, so that's my first one. And here I'm just going to, this is if I didn't give it an MFT entry. I'm going to order it by the MFT entry and then the date and time. Here's the query. If I did give an MFT record, and I say, all right, I'm going to add that, where this MFT entry has to be what you pass. When I run that, I'll get something kind of like this. So this says this file, main HTML. By the way, I just randomly picked an MFT entry number. Here's a directory entry, if you will. It's from an index block or index buffer. Here's the long file name. Here's the short file name, short file name. That one's from the standard info. Then I have file name twice. Here's another directory entry, file name. So you can see I have multiple entries. So I've got modification, timestamps, access timestamps, record change, and then creation timestamps. So I can look through something like this and look for something funny. Now, one thing I probably should do at some point is maybe write a script that somewhat automates that, just sort of flags things as this looks suspicious, right? I haven't actually done that yet, but maybe in my copious free time, maybe that'll happen. We'll see. All right, a little bit about timestamps. First, a disclaimer. Microsoft can't seem to decide how this stuff should work. The rules can have changed in the past, could change in the future. So if you're doing some analysis a couple years from now, you might want to visit Microsoft's website and just see if these timestamp rules still apply. There's actually a complicated set of rules. If you take a file and you copy it from one NTFS file system to another NTFS file system, there's a set of rules for that and how that works. But if you copy it from NTFS to FAT, there's a different set of rules. If you go from FAT to NTFS, there's a different set of rules. So it's all really weird in how that works. So here are some of those rules. If you copy a file, when you copied it, you have the same standard info modification time. Right? All the other timestamps in the file name attribute or attributes in standard info, they get changed. That's the way it works today when you copy a file. If you just access a file, in the standard info timestamp, there's no change. And it will change the access timestamp in that attribute if you're running something earlier than Vista. If you're running something later than Vista, it doesn't change that. So you might think, well, that's kind of weird. If I access a file and there's an access timestamp, why doesn't it change that? And the answer is, I don't know. Right? There are ways of changing if that gets updated at all, but this is just those two MFT entries. Right? So where does it get changed? It gets changed by default in those index buffers, in the directory entries, but not in the files entries themselves. Right? If you modify a file, by modify a file, we mean you save the contents. If you have a dumb editor, you save the contents and they haven't really changed, operating system doesn't know that. It's going to say, oh, you have changed this file. So if I save a file, standard info, modification time gets changed, but the file name attribute or attributes, that timestamp doesn't get changed. So it's not a problem if these two differ, right? If these two timestamps differ, you might initially think, ooh, some evil hacker has done something to my system. But the truth is, that's what's supposed to happen, is that it only changes one place. So Okay, that's a little weird, but that's the way that it is. So if you see these timestamps synchronized, then I might be concerned. Unless they both have a modification time of when the file was created, then that's also normal. If you delete a file in NTFS, so I said we spent a whole semester on NTFS at the university because it is a little bit complicated. One thing that is not complicated at all when it comes to NTFS is getting a file back that's been deleted. When you delete a file in NTFS, there is one bit in the MFT entry. It just gets toggled. It says this thing's not in use. And of course, the clusters get marked as available. So undeleting that file is super easy. You toggle the bit back. And that's it. It's done. FAT, especially FAT32, turns out super complicated. FAT32, the worst thing about it, depending on exactly what version of Windows you're running and how you deleted a file, it will zero out the high word of the starting cluster. So you're not sure where this file used to start. So you have to guess, and there's a lot of things that you can do for that. So I have some scripts that will do a pretty good job of recovering most files from a FAT file system. But there are some assumptions that you have to make there. If you rename a file, the only thing it changes is the record change time in standard info. It's kind of weird to me that the record change time in the file name, the thing you just changed, that doesn't change. But this one does. Don't know why. It's just the way it is. If you move a file from one part of a volume to the same volume, it'll change these two timestamps, modification and record change. They're changed to the same value as what's over here in standard info. And the record change is changed to the current time, the current date and time. If you move a file to a new volume, it changes everything in both except for modification and creation times. All right, to summarize that, and then I'll risk it all with a demo. Didn't want to start 4 slides in. Some people are a little bit more bold than me today, but the rules are kind of complicated. I think you might agree on that. Because of that, it's easy for attackers to screw this up. Some standard tools are kind of slow. We give you the example of autopsy, taking over 5 hours, as opposed to my scripts that took less than 2 minutes. The other thing about those standard tools, they're limited. You only get whatever views the tool's author decided you should have. And with a little scripting and a nice database, you can make it super fun and super fast. All right. So let me go ahead and see if we can do this. All right, so the first thing I want to do is I've got a couple of files here. And I have, right here, I have this subject image. Looks like it's about 26 gigabytes. And I want to get that MFT file out. I want to extract that. So I'm going to use my little extraction script that I have here, extract.py. Again, all these scripts you can download for free off of windowsforensicsbook.com. If you want to look at Linux systems, there's another website, linuxforensicsbook.com. There's kind of a pattern here. You can also download all the code from this little book for free from that site. Okay. So if I go ahead and look at this real quick. Ooh, That's very, very small.
It's weird that it loses it on there but keeps it on the recording. What's that? It stayed up there.
Oh, that's extra weird. Let's try that.
I looked over and it was still there. Still there.
Okay. So this is a pretty simple script. It starts off with a shebang line, runs Python 3, import a couple of things, and my main method, I have a couple options. You have to give it an image file. You have to give it an offset that says how many sectors in does your file system start. And then the entry for the thing you want to extract. Now it turns out that the MFT itself is stored in the MFT. It's entry 0. Right? So we're going to extract entry 0. I can optionally give it a directory. I can optionally give it an MFT file, which I won't because I need to get that. And then there's a flag for if you extract an index buffer. So it's the directory you point at. I can get something that often is called a $I30 file that you can use for different processing. You can look that up if you want to learn more about that one. So here's my basic script. So I want to go ahead and run this extract. Now the first thing I need to know is where does my file system start? I swear I didn't even touch it. Okay, there we go. And the way to do that is if you run fdisk on your file. You do p to print. You'll see. Well, that's weird. Okay, here it is. There's where my thing started. Sector 206,848. That's where my file system of interest started. It's almost like if I step on the power cord, this goes out. It's weird. That is totally weird. Okay.
You were not moving it.
Yeah, exactly. All right, so let's see if I can do this. Extract, and I want to give it PA-Win7 subject -O206848. I would like to extract entry 0. And it says extracting file $MFT. So normally that file is called $MFT. $signs are really, really bad in your file names, especially on Linux, because that indicates a shell variable. And so I said, oh, let me detect those bad characters, and I just substituted the word $. Right? So now I've gotten that MFT file extracted. I swear I'm not really touching anything here. Okay. And so now I want to run my other script called get max, and it's going to also need an image file, an offset, and it's going to need an MFT file. And I'm going to redirect that whole thing to SecureWV CSV. And now it's going to run. I forgot to throw time in front of that, but you'll see it'll take less than 30 seconds, I'm sure. This is a really wimpy laptop. It's an i3. I just like it for presentations because it's small. So I would normally have a much beefier computer than this. All right, and that's done. So now what? Well, I already installed my SQL. let me go ahead, create a database. I'll use MySQL admin. I'll create SecureWV. MySQL. I'm like, that's weird. I had MySQL installed. Okay, that's done. Now I need to go ahead and import some stuff. I'm going to go ahead and run gedit on this little file, and I'm going to copy and paste. So here's my first bit. This is going to create a table. No. Okay, so now I want to run up my SQL. Connect to SecureWV. Control-Shift-V. Maybe when it comes back, there you go, it worked. So now what do I need to do? I want to load my data. So I'm going to run this command. Let me go ahead and change this. Now, one thing I didn't mention earlier, notice this location. This is done as a security measure. So it would be a really bad thing if I could just load a file from anywhere into my database. Let's say I compromise my web server and I want to load information into the database to maybe create some new users or something bad. I don't want to be able to do that. So I have to be able to all right. It's officially annoying me now. But I have to be able to control where these files are coming from. So if I go to this directory and I want to move that file, I need sudo. I'll just copy it. Copy this to var lib mysql-files dot. I'm copying my CSV file, or at least I will as soon as I can stop. If I can successfully type my password, that is. Oh. Okay. Now I can fix that part. There we go. Okay. So now I fixed that. Now I can go back here and paste this load command. Of course, I don't need to use the time command in my SQL because it actually tells me how long this is going to take. So we created a few rows in about 11 seconds. Now what? Now I need to create the second table, and then I'll populate it. So I'll create my table. That's done. And then I have my insert commands. Right. So a little under 4 seconds. A little under 5. Back to 4. All right, so now I have everything loaded. So what can I do now? Well, now I could pretty easily run one of my scripts. I have print timeline, print file timeline. So let's go ahead and start with print timeline. And I'm going to say I just want everything from 2014-01-01. And I'm going to redirect this to a file. And I'll call it timeline CSV. Oh. It would help if I gave it a database. So SecureWV. It's going to ask me for my password. And it's going to go off. And it's going to create my file. And now I'm going to go ahead and I'm going to use Calc. And I'll bring up this file in Calc so that I can look at it in a little bit more user-friendly way. There's my import in Calc. I have tab selected. I can say this one is a date in year, month, day format. Click OK. It's bringing it up, of course, on my other screen. Let's see if I can pull it over. It's going to take a little while. I think it's probably loading about 1.2 million rows into the spreadsheet. And here you go. Now I have all of my entries in a semi-pretty format. Right. Okay. And that's all I had to say about that. Any questions? Yes, sir.
How big is that image file? How many files are we talking? Because you said there's like 1.2 million records.
Yeah, so there's about 300,000 files on that.
So how big was the image file?
About 26 gig. So it's a bit on the smaller side. You know, why is it that small? Well, for one thing, this is a image that I use for a class I did at Pen Tester Academy. And people don't want to download 2 terabyte image files in order to learn some stuff. But there's that. Other questions? Yeah.
It's the size of the pages that goes up, like say, a 1 terabyte is like would be a reasonable big system. Like how does that scale in linear fashion?
It's linear, yeah. Yeah, because all I'm doing in my Python scripts is I'm processing the MFT, right? So it's going to be 100% linear, and I'm going to make a CSV file, and I'm going to drop that into the database. And again, having a proper database, it's going to give you linear times instead of something else. So, all right. Other questions? Yes, sir.
2014. It looks like it's going to refer to.
That was. But that's correct. That is an interesting question. That's weird because I didn't get that one before. I might have to look into that. But yeah, something a little weird might have happened there. But yeah, because normally I would expect, this is about when I stopped using this last year, December. This is just an image I created for a class. So that is a bit weird. Oh, you know what it is? No, it's not that. I was going to say it might have been a misformatted date or something. I'll have to look into that one. That's the first time I've ever seen something like that happen, which is kind of odd because I've done this exact same query before. So
Obviously been using it for a while.
something weird must have happened there. But all right.
The demo guy, the same thing with them making your screen go in and out.
So where can you get all these scripts?
The website.
What's the website? You want a free book? All right. Does anyone else have another question?
What's your favorite beer that you want me to buy?
Ooh, if you can get this Belgian triple bock beer, Duvel, if you're familiar, that'd be great. But all right, where can you find scripts to work with Linux subjects?
LinuxForensicsBook.com.
I think you were first. All right.